Hello, and welcome back. So, we are going to be talking about factors. Factors are the numbers you multiply together to get another number. So, that's a little bit confusing. What we're going to do is start with an example, say 12. And I want to find all the factors of 12. And 12 is a pretty nice number, it's small. So some factors of 12 are, let's say, 1 and 12, because 1 times 12 is, in fact, 12. So 1 here is what we call a factor. 12 is also a factor. And together they multiply to get us 12. We could also find other factors like 2 times 6, which also gets us 12. So 2 is a factor, and 6 is a factor. Hang on 2 seconds. Okay, so other factors of 12 are 3 and 4, because 3 times 4 gets us 12. So we could list all these factors. We got 1, we got 2, we got 3, we got 4, and we do prefer to list them in ascending order, so that's why I'm doing this. We got 6 and finally got 12. And here's the factors of 12. Let's get a little bit crazy. Let's say I gave us a huge number, and I ask us to find all, and I mean all, factors of, I don't know. Let's give ourselves a pretty nice number. Let's say 110. Okay? So, to start us off, the easiest one to pick is 1, because you'll always have 1 times the number that you're looking at, because 1 times anything is the same thing. So we'll always have 1. So far, let's go ahead and start our list of factors. And our first one we have is 1, and we also have 110. Now, I'm not going to list them in the nice order. I'm just going to start listing all of the ones I find. Next up, since this ends in a 0, for sure, that's even, right? 2 can go into this number. Now, if you don't know how many times 2 can go into 110, go off to the side on some scrap paper and do the long division. And you go 2 times 5 is the closest you'll get to 11. And you got 10. Subtract 1, bring down the 0. 2 times 5 is exactly 10. And look at that, no remainder. So 2 times 55 gets us 110. So we can add them to our list of factors. So we'll go ahead. We got 2 and we got 55. All right, next up, I'm going to try 3. Now, in order for 3 to divide into a number, the sum of the digits must be divisible by 3. So if we take 1 plus 0, we got 1 plus 1 is 2, plus 0 is 2. Is 2 divisible by 3? No, so 3 won't work. Now we'll move on. We could try 4, see if 4 works. 4's divisibility depends greatly on the last 2 digits. If that last 2 digit is divisible by 4, then so is the number. 10 is not divisible by 4, so 4 probably won't go into it. But if we wanted to, we could check. Okay? And that's how we're going to have to be able to find all factors. We got to check. So 4 into 110, well, 4 times 2 is 8. Subtract, we got 3, bring down the 0. 4 times 7 is 28. And we're just short by a little bit. So 4 doesn't work. Okay. Well, next up is 5. We'll see if 5 works. Since the last digit is a 0, that means for sure 5 can go into this number. Now, how many times 5 goes in there, we have to figure out. And if you don't know, you just do the long division. 5 times 2 is 10. Subtract, we got 1, bring down the 0. 5 times 2 is 10. And no remainder. So 5 times 22 gets us 110. So we can add them to our list of factors. We have 5 and 22. All right, let's continue on. We could test 6, but we already know 6 isn't going to work out because 2 and 3 have to work in order for 6 to divide into a number. And since 3 didn't work, 6 won't work. We can try 7. I don't really know anything too special about 7. Maybe you have the rules memorized. If you don't, we'll check by long dividing. 7 times 1 is the closest we get. Subtract, we got 4, bring down the 0. 7 times 5 is 35. And we're at a standstill. So 7 will not work. Alright, don't give up hope. Maybe 8 would work. 8 won't work because 4 didn't work. And 4 times 2 gets us 8, so 4 should work into it. If you don't trust me, you go ahead and you say, let's do the long division. Now you might be shouting at your screen, I trust you, don't do it, but I'm going to do it anyways. I can torture you. You can skip the video if you want to. So we go 8 times 1 is 8. Subtract, we got 3. Bring down the 0. And look at that. Just like I promised you, we're not going to have anything too good. 8 times 3 is the closest we get with 24. And we have a remainder of 6. So 8 doesn't work either. Maybe 9 will work. Chances are slim because 3 didn't work, right? And in order for 9 to work, 3 would have to. The cheat for 9 is add up the digits. Well, 1 plus 1 is 2, plus 0 is still 2. And 2 is not divisible by 9, so that won't work either. Okay, you might be saying, well, then I'm done. There's no more. Well, that's not necessarily true. We got to keep going. And I'll tell you when we know when we can stop. We can try after 9. Let's do 10. Well, what times 10 will get us 110? Well, 10 times 11 is 110. Perfect. So we got some more. And now let's see. What's after 10? 11. Ooh, this sounds familiar. I think we already did that. We said 11 times 10 was 110. Well, I don't need to repeat myself. I must have found all factors then. So in order to find all factors, you must start to repeat yourself when you're listing off your factors. As soon as you repeat yourself, you can stop. You found all of them. All right? For fun, try on your own. I know you guys are adventurous. Try finding all factors of 120. And if you can, I'll tell you right now, there's 8 of them. 8 factors total. Okay? So that will be a fun journey. Give it a shot. Now what we're going to go ahead and do now is talk about special numbers. Because factors, look how many I have. They're not very unique. Factors, we could be here all day if you give me a really big number, like 120. What we're going to do is come up with a unique way to start describing numbers. And the easiest way is through prime numbers. I have 2 definitions here of what a prime number is. A prime number can be divided evenly only by 1 or itself. And what you can think about divided evenly, that's the same thing as saying divisible. My pen is dragging, so I'm sorry about divisible being written so weird. Kind of looks cool. So divisible means no remainder. So that's all divided evenly. The other definition we have is a prime number has exactly 2, and I mean exactly 2 factors, 1 and itself. All right, now the second definition is the better definition. The first definition is usually easier for brains to comprehend. So we're going to start with the number 2, and I want to know is 2 prime? Well, let's see. We're going to list all factors of 2. Not very difficult. We'll start with 1. 1 times 2 is 2. Okay? Now we'll go on. After 1 is 2. And hey, look at that. We repeated ourselves. We still have the same factors, 1 and 2. I'm sorry, factors. So what we are going to do now is say, well, 2 must be prime. Well, let's see another number. How about 3? And I get to bore you with this. Give me some fun, okay? 1 times 3 is in fact 3. All right, after 1, we'll try 2. 2 can't go into 3 evenly, so that ain't working. Next digit's 3, and hey, look, we repeated ourselves, so we found all factors, 1 and 3. So 3 is prime. And we can continue on in this fashion. Try 4. We have 1 times 4 is 4. Okay, let's go off to a good start. Next up, 2. Well, hey, 2 times 2 is 4. And look at that. We repeated ourselves right there. So we found all factors. We have 1, 2, and 4. But there's 3 factors. And if it's more than 2, we need exactly 2. That's what the rule said. Then it's not prime. So what do we call for? Not prime? Nah, we got to come up with a better name. We call it composite. And I probably should have looked up how to spell composite before I typed it. So there's composite. Double check me on the spelling. So we have prime numbers, we have composite numbers, and then we have things that are neither. Now, composite means we are going to have more than 2. So let's write that. So composite. And we're going with the crazy spelling that I have, okay? If you find a better spelling, go with it. Composite means there's more than 2 factors. Doesn't mean just not prime. It means there was more than 2 factors. What about 1? I skipped 1, right? I just started with 2. That was kind of mean of me. Poor 1 didn't get in on it. So let's talk about 1 real quick. 1. Let's find the factors of 1. Well, 1 times 1 is 1. And I already repeated myself, so I have 1, which is my factor. Oh, but there's only 1. I need exactly 2 in order for it to be prime. So 1 is not prime. You need exactly 2 factors. So he's not prime, but he doesn't have more than 2 factors. He only has the 1 factor. So he's a neither. He's neither composite or prime. Well, that's pretty much it. He's kind of sad that way. Alrighty. So now that we've learned a bit about factors, the next thing we're going to talk about is the prime factorization. Prime numbers are unique. Factorizations, not so unique. In case you're wondering what a factorization is, let me scoot back previous in our slide where I said find all factors of 110. 1 times 110 is a factorization. 2 times 55 is a factorization. What it means is write it as a multiplication, write it as a product. That's what a factorization is. Notice I came up with 4 different alternatives of writing 110 in multiplication form. 4 different answers. That's not good for math. You know how we like things. This is the answer. This is set in stone. So what we came up with is a unique way to describe a product of a number or a factorization of a number. And we call it the prime factorization. So let's take 110. And I'm going to write him as a product of only prime numbers. So what we do is we usually build a tree. We think of 2 numbers that can get us 110, other than 1 and 110, because that's boring. 1 in itself is boring. So let's see. We know 2 times 55 got us 110. Now we're going to look at these 2 numbers. 2 is prime, so I'm going to circle him because he's a prime number. There's no further I can break it down except into 2 in itself. 2 and 1, I'm sorry, 1 in itself. And that's not interesting to us, so we're looking for prime numbers. 1 is not a prime number, remember that. Now 55, I can actually think of further breakdown of it. 5 times 11 will get us 55. 5 is a prime number because all it has is 1 and itself. 11 is a prime number because all he has is 1 in himself. So a unique factorization is 2 times 5 times 11. And multiply that number together, and sure enough, you'll get 110. These require a little bit more in-person explanation, I feel. I can do more online if you guys want me to. Just write a comment or email me. But I'm going to leave it at that. We're going to spend a lot of time doing prime factorizations. What I need you guys to get familiar with is your prime numbers. Maybe even list them off. You got 2, 3, you got 5, you head into 7. 9 is not prime. 3 times 3 gets you 9, so there's more than 2 factors. The next one is 11, continue on, 13, and you can go on. You can find lists of them. Try to get familiar with as high as you can go, as you're comfortable with. You'll discover that we don't go too crazy. Maybe like 19, is the worst we really get with some of our prime numbers, but there is more out there. All right, so that is all. Until next time,